Hey everyone, JNation. I am so happy to be here. This is my first time, not just on JNation or this city, but first time in Portugal. I'm just in awe of how beautiful the country is. Thank you so much for having this beautiful country. Applause to yourself. All the Portuguese people clap, everyone else doesn't. So, this is going to be sort of a small interactive journey, a history lesson of tooling around the front-end stuff, and I'm just messing with you, it's all right, I made it up. Anyway, okay, that went much better than I expected. Anyway, so this is a sort of an interactive journey and a history lesson of how we come to have JavaScript and all the sort of the zoo of all the tooling and things around it that we have right now. This is my name, I know it's on the screen. Thank you so much, Daniel, for spelling it out. But I don't have the slide with fancy titles where you sort of have to sell yourself up to the audience. I don't know. This is just my name, and that's it. We don't have much time, so let's keep going. I am cursed, and I am cursed not because I am sort of. I'm not cursed because I broke my hands delivering this talk and I had to do it like this. And thank you so much for all the friends who helped me go through this during the two conferences. But I am cursed because no matter what team I join, no matter what I work on, I always end up sort of configuring webpack and doing, all the most boring bits of the front-end pipeline. I always do that, no matter what I do. I start in billing, I end up in developer experience. This is just what I do now. This is my life. Anyway, let's go all the way to beginning, but not this far. The prehistory. It is 1990-something, and we have the Web 1.0. It was as beautiful as it was pure. We had, we just had HTML and maybe a bit of CSS. Later on, the Netscape Navigator team got this dude up and said, could you maybe develop like a scripting language to spice things up a little bit? And by the way, you have 10 days. So this is how the JavaScript was born, and everything went downhill from there. Fast forward, let's say 6-ish years, Internet Explorer is now dominating the browser space. This is early 2000s, and we have Web 2.0. Everything, all the logotypes are shiny, and we have things like Ajax, asynchronous JavaScript and XML. You can now replace things in a page without reloading it. Then there are browser wars. jQuery comes in to save the day, if you remember that. But, things just go more and more complicated over the years, and then, as naturally in any historical period, we now come to the Renaissance. So if you ask me, hey, what do I need to know in order to sort of get into the front-end development? What do I need to learn? What are the things I need to know? I said, oh, it's easy. You just need to learn Sass, less stylus, CSS, and Jest. We have a couple of those, things to spice your pages up. By the way, no one really uses JavaScript. We have CoffeeScript, Flow, LiveScript, Haggle TypeScript just coming out, and Rspack, Reasonable. By the way, you need to somehow bundle all of this and build. You have the Bower, Babel, Yarn, NPM, Grunt, GSHint, ESLint. You need to also test this. There's just so much stuff. And all of those things, if you remember, when there was an explosion of tools, all of those tools were running on your own very miserable computer. And it was horrible. I don't know if you experienced that, but it's just, whenever you do something, you just wait for a hot reload to complete. I suffered through this, I hated it. Or if it's not running on your computer, it's running in the cloud or on someone else's computer, which could cost money. Right, so let's take a look at typical, that was 2020-ish release pipeline. I hope it's big enough. So it starts with the code changes. Then, assuming we're using TypeScript, we perform type checks and generate types definitions. Later on, we transcribe the newer JavaScript to older JavaScript if we need to do that, bundle things together. Then we run bundle reliant tests, and then if checks are green, we deliver to CDN. Also, same things for tests, and also, of course, code quality, lint. Hi, Josh. And deliver to CDN, of course. And let's take a look at 2021. I was working in a company called TopTal, and we had this massive monorepo, which was 1.5 million lines of code, or something like that. And let's take a look at the real numbers. So for just performing type checks and generating type tests and everything like that, that was 3.5 minutes of waiting for the full run. And transforming source code was 6.5 minutes. This is sort of the bundling thing and where the Babel run. Sort of transforming source code for tests was 4 minutes. And anything else. This is really slow animation. I should have fixed that. Yeah. Running test was 45 minutes. We had a lot of tests. We're not going to talk about like parallelization and things like that, but it's not a topic for another talk. Code quality linting could take up to 15 minutes. I'm really sorry for that, but I was not the one who created this mess. And bundle roll tests, which is sort of like full user flows up to 1 hour. That's also another story. Anyway, now, let's talk about the modern history. This is where we are right now. These are sort of the things most people know, some people don't, or this is the things we're going to talk about right now, right? So all of those tools I mentioned before, these tools were not made by bad engineers. These are amazing engineers that sort of paved the road, right? But because there were JavaScript engineers, all of those tools are written in JavaScript. And of course, yes, JavaScript bad, JavaScript slow. You know how people started writing Mo code and tools just couldn't keep up with the amount of modules and files that we have, right? So what do? We write this in a language that is closer to the metal. And now, okay. So this is sort of a convention that I made up. It doesn't really exist anywhere else, but let's imagine we have two sort of main categories of tools, conventional tools and foundational tools. You could say conventional tools are things like webpack, which just calls, it is a bundler, but it is also a task runner, which calls a lot of other tools by itself. And foundational tools are tools like Babel itself. So it's something that you just call as a part of your sort of larger tool chain. Let's talk about foundational tools of the new era. First of all, these are the things that you get if you lock a couple of cracked engineers in a COVID lockdown. They make this. So that is how we got SWC, which is a speedy web compiler. And it is written in Rust by Dong-Yoon Kang. I hope that's correct. And it is very fast. It can bundle with very big limitations. And hello, it can minify as well. And yes, then we get ESBuild, which is an ECMAScript builder. It's not a really good name in my opinion, but there it is. It's written in Go by Evan Wallace. It is fast. It can bundle with some limitations, and it can minify as well. Here's the thing. This probably is small enough, but these are really old benchmarks. This was 2021. But just look at this. This is Babel. It's compiling a large JSX React code base. Babel, TypeScript, and those are ESBuild and SWC. This is how fast they were. And at the time, it was groundbreaking, right? So why not just use them? There was also 2021, I did this talk a couple of times, things are changing. At that time, there was no existing community support. You can't really handle everything, can't handle bundling really well, and the benefits of adoption could not be comparable to sort of the cost of implementation. But now, things have changed a lot. And now, there's pretty much about both of those tools, just that they don't really do bundling well enough. Right, let's take the same app that we used to have, and then we replace Babel with SWC. We still have Webpack, but that brings down the total compilation time from 6.5 minutes to 2 minutes, which is very good. And of course, the tests now take 3 minutes to compile, which is amazing. Now, next foundational tool, Lightning CSS. Very simple thing. It was made by a team from Parcel. So what they did is they took, it is CSS minifier, bundler, and transformer that replaces things like post CSS from time to time, and it's based on a Rust crate from Firefox to parse. So basically what it does, it's using the Firefox internals to quickly and efficiently parse and transform CSS. If you don't know what it is, you might have used it as a part of Tailwind CSS or Next.js. I hope this is the correct logo and I will not get sued by Vercel. Right, so yeah, that's the build time comparison. Pretty fast, all good. Right, now, onto probably the biggest thing that we have here. This is the JavaScript oxidation compiler. And it is a parser. It is a linter, it is a resolver, and it is a transformer, but it also is so much more. But for now, we're just going to focus on it being a linter. Just remember this logo. It's going to come in really handy later on. And yeah, as you can see, you can almost don't see. I know, yes, lint is very good. This is not a talk about linters. This is just a talk about alternatives. I keep apologizing to people rooting for, what was it? ESLint, of course. Right. So pretty fast compared to ESLint. Very good. Moving on. Let's talk about conventional tools of the new era. These are sort of the bigger, powerful tools, all in one kind of thing. Right? Vite. Anyone here uses Vite? Very good. There's a lot of people. And, well, not all of them, but we'll see. Not the entire room. If you don't know what Vite is, I could quickly explain. So let's say you have webpack set up, or rollup, maybe parcel. So what they do is they take your entry point and then sort of traverse the graph around and make one big bundle, like a development server, and only then the development server is ready, and you can sort of start using your app and working on it. But with Vite, what happens is the individual files got transpiled during the request time, so the development server is ready immediately, which looks magical. Like when I first tried it, this was, well, it looks, oh, wait, forgot, sorry, this is the wrong slide. Anyway, you might have asked me, like, what about the Node modules? Yes, you can't just do that. The Node modules are handled by ESBuild right before the server starts. All the Node modules are sort of transpiled once by ESBuild. Whew. Great. Why Vite 1? In fact, I think in the current state of things, Vite pretty much won the sort of the basis of creating any simple app, anything that is like a front-end, SPA, whatever else. You just ask anyone who is seasoned enough and say, yeah, bro, just use Vite. It's good enough for everything. So Vite still uses the traditional sort of battle-tested bundle approach in production. So under the hood, Vite uses rollup in production. So when you do a production build, it is still the same thing. You still have Babel, and it's still all that sort of battle-tested JavaScript bundler approach. And in development, yes, you get the ultimate developer experience. Right? It's very fast, it's very nice, full of plugins for just about everything you want. But, oh yeah, this is sort of an app that I ported from, because you can see the Vite is already done while I was talking, and the webpack is sort of catching up. This is how pretty fast it is. Right. Wait, what is going on here? I'm sorry. That's not supposed to be here. OK, now we're good. So yes, as you can see, dev mode is fast things, production mode, slow things. That's it. Right. But, when things scale up, imagine you are a multi-billion-dollar corporation, and you have all of those sort of apps and pipelines you're running every day, thousands, maybe tens of thousands, hundreds of thousands times per day. This is not enough for you. You need more. You need faster, because that costs money. That scales up really fast. So, there was a spoiler. Right. Now, with Vite, you sort of have to select either its consistency or developer happiness. Developers are really happy with Vite, but if you have a bug that is only appearing in production, your development build does not ever reflect that, because it's very different. Now, the answer, of course, Rspack. And this is sort of a labor of love of many people. Like, this is an amazing team, mainly led by people at ByteDance. So Rspack is a thing which was originally introduced as they wanted to keep the same API as Webpack and reach feature parity, so this could be a drop-in replacement. Webpack is undoubtedly like one of the greatest creations of the front-end ecosystem world. Its ecosystem is vast, a lot of plugins, people know how to work with it, even though sometimes, yes, you need PhD in Webpack configs to sort of figure anything out. This is why there are a lot of wrappers and different tools around that. Right. So Rspack also introduces a bunch of other sort of child things. There's Rspack, RsBuild, there's RsLib for libraries, there is Doctor, RsTest. This is to run tests faster, right? And how could it be? Because this is a tremendous amount of work, but this is just about if you're a big corporation and you have sort of the money to rain on the people who can make this happen, this is going to pay off for you in the long run. This is why you need that. Perfect. OK. Right. Let's take a look at the Rspack front-end release pipeline. So we replace Webpack with Rspack. And we go down to 20 seconds in the build time, which is incredible. Right. Maybe I'll just walk around here. Right. Now let's talk about Parcel. You might ask, why is Parcel here? It's an old thing. No one uses that, only for like small toy projects. But the Rspack team is slowly sort of expanding into the new world as well. So they replaced Babel with SWC, and in fact, they made Lightning CSS. So if you have sort of a small project and you don't want to even think about configuring anything, Parcel is a very safe bet for you. Now, roll down. Roll down is a roll up written in Rust. That's it. It is same thing as Rspack, but now it's for rollup. Like, we're going to talk about this later as well. And of course, there is TurboPack by Vercel. And this is also authored by a person, by Tobias, who was the original author of Webpack. Can you use TurboPack now? Sort of, as a part of Next.js. Setup. Is it open source? Not really. Well, we'll see how it goes. This is the Vercel dream. This is OK, I won't even talk about this. I literally like the ideas behind it, but we don't have enough time. I don't even know why this slide is here. Oh, let's talk about Biome. Biome is a tool that is trying to solve bundling, compiling, doc generations, formatting, linting, minification, testing, type checking, and much more. But what we have achieved is code formatting. Let's see. This is sort of the dream setup, right? Let's see, we have a couple of steps of the pipeline. We have code enhancement, code quality, and code delivery. We have TypeScript and GSX transforms. We have Prettier, we have ESLint, and Cursor and Webpack for code delivery. Each one of those tools has to do the same thing. It's parse code and build AST, then perform some sort of calculations or AST, and then produce a result as a result of modifying the said AST. Anyone sees the problem with some sort of things we could figure it out, to make it faster somehow? Yes? Of course, yeah. I'm just messing. Yeah, of course, all of those same tools do the same thing, but differently. And if we replace all of this with one single unified AST, we will achieve the dream, right? So yeah, Biome now is a code formatter, so let's sort of plug it in again in our pipeline, and we shall have 5 seconds of quad quality and linting. But now, why do we still live like we're in Renaissance? If you waste your time on long pipelines, if it just makes you mad, please do that. Please migrate. Please at least make an effort to migrate. I know it might seem like it's a hard thing to sell to the business, but yeah, it's not like if you're a small company, you're unlikely to spend a lot of time on CI. So, but overall, we condensed 25.5 minutes to 33 seconds, which is roughly $6,000 per year on such standard GitHub runners, which is just pennies for any big corporation. But the developer time is priceless. Now, let's talk about the dream of the unified JavaScript toolchain. The dream of Biome, even though the development sort of halted overall, but the dream lives on. Rolldown, Vite, and OXC are now backed up by a sort of the unified company called Void0. And the idea behind it is that over time we will achieve sort of Rolldown will replace rollup in Vite. OK, let me actually show you. Remember the icons and the names. So rollup, OXC is a AST parser, transformer, resolver, and minifier. Then this is what Rolldown is based on. And now the Rolldown is going to be integrated into Vite. And then ESBuild and rollup are going to go away. And also, this is the formatter and linter. You could use the same. And all of this is backed up by Void0. Are you following what I'm saying, right? We're going to solve all the problems. We're going to have the unified JavaScript toolchain. The dream lives on. The dream lives on. Wait, what? All right. The dream lives on. Also, Rspack. The people behind Rspack are now working on the unified JavaScript toolchain. We might have things to run tests with Rspack and many other things. The dream lives on. We also are going to have TurboPack integrating with TurboRepo, so they're going to have the shared internals, and we're going to achieve the dream, and we're going to have the unified JavaScript toolchain. Right. OK. Whew. Now let's talk about the future. Why do we build and bundle in the first place? We build and bundle because browsers don't understand the code we want to write. Network overhead is a thing, so we can't just ship thousands of files to your production bundle. And cache invalidation is sort of hard, right? Let's talk about some things that are coming or might be already here. Let's talk about import maps. Import maps is sort of a thing that allows your browsers to understand the syntax of import something from something without file names. And by using import maps, you can also selectively invalidate cache, which allows you to essentially ship ES6 modules to the browser. Well, there are some people preaching that we already achieved the bundleless, but we're not going to talk about this, right? There's HTTP3, which sort of helps with the problem of network overhead. Don't have enough time, but I'm not going to talk about whole line blocking, but we do solve some of the problems with sort of many files shipped to browser equals slow, right? And of course, TypeScript. TypeScript was, for the longest time, I had this slide here, but now I am so happy I don't need to talk about any of this. Are you working on TypeScript something? And then I interviewed Boshan on Twitter, and he said, yeah, I tried to, it's just not feasible for a small company like us. But no, now we have TypeScript and Go, yes. And we already celebrated to that at the beginning of the day today, so I'm not going to talk about it, right? There's type annotations in the future. Maybe we will have sort of will we have types in JavaScript in the browser without any developer tools? I don't know. It is sort of a very controversial-ish. It's the fourth most starred proposal on TC49. It's stage 1. It's years to be implemented or not implemented. It's a long time coming. Right? I don't think we're going to see it in a lifetime. Who knows, right? So in the future, imagine we will never have to even think about writing something. There will be no need for tooling. All the tooling will be in the browser, in the spec, in the network level. Everything will be fast and instant. And most importantly, all the tools that I mentioned, they are vital to the ecosystem. And it's going to be years and years until, because for new tools, do you have to learn Rust to write a plugin for your linter? No, you can just use ESLint. This is why ESLint is good. And this is why all of those tools are still very important. If you have sort of the financials to spare, your company has that, please support the authors and maintainers of all those tools, not just the one above the water, but underwater as well. Right. Anyway, thank you so much for having me here. If you scan this QR code, you can find my talks, my information, and everything else. And thank you so much.